We need to determine if each table represents a function or not a function. To be a function, every input has to have at most one output. So you can't have two different outputs for the same input. If we look at table A, none of the inputs are repeated. So every input has one output. Even though -7 has the same output as -5. You input a -7 or a -5, you get a -1 out. That's fine, as long as you don't repeat inputs. So this is considered a function. Example B over here, we repeat the input 5. So when you input 5, you could get a 6 or you could get a -6. So for the same input of 5, you don't know if you're going to get a 6 or a -6 because there's two different outputs. That means it is not considered a function. Now, if you need to remember why you can repeat outputs but not repeat inputs with different outputs, I like to give the example of training a dog. So when you're training a dog, you might give them treats if they do something good, or if they do something bad, you might give them a spray with a little spray bottle. So for example, if a dog did shake hands, that's a trick dogs can do, they'd get a treat, so they know it's good. If they play dead, they'd also get a treat. So it's the same output for two different inputs, but the dog's not confused because they know if I do something good, whatever that good thing is, I get a treat. On the opposite side, if they did something bad, like they pee on the carpet, then you might spray them. But if the dog pee on the carpet, one day they get sprayed, and then a different day they also pee on the carpet, but they get a treat, they don't know if peeing on the carpet is good or bad because they got a reward and a punishment for the same activity. So doing the same input with two different outputs makes it so the dog does not know how to function. Remember, you can repeat outputs, but if you have the same input with two different outputs, it's not a function.